right? So in the same way, we can put, and we should put the ground here, the ground or negative. Now, when I put ground here, so all these are now grounded. But then it's easy to make connections from this to here. Because you may have many components across the whole thing and you have to energize. In this case, we just have one LED. So in that case, then you look for those small connectors like is given here. Later on.
Okay.
So let me open this guy. It says QC is closed or something. So here we have a bunch of connectors. So I'll just take one of those. Okay, let me see how they have taped it up really well on all three sides.
Is this project due next week or 2 weeks from now?
It's due next week. So what I'm doing now is I'm taking one of the black connectors and all I'm doing is I'm going to put this between this guy and hold on, let me do it and then I'll show you what I've done. So what I've done is I put this black thing to connect between, so there was this negative terminal of the battery plugged in here, and it's all same. And from here, I've made a jumper to here. Why here? Because this is then connected to the resistance that runs on the same line. This resistance runs on the same. So I've done only on this side. I haven't made connection with the other side of the LED. It's the same way you can do that. So in that case, we can, instead of using black, I can use red or any different color. Simple reason just to distinguish that which side is what. Let me just complete it so you guys can see that. All right, so I'll get to that. Let me show you a video on simple concepts of Blackboard, just to recap things that we've been doing. Right? Just wait a second. Let me get that up and going. Can you see black screen? second, I think sharing is stopped or something. Can you see the video?
Electronic spaces.
Yes.
In this episode, we're going to have a look at breadboards, what they're about, and how to use them. So to start off with, breadboards are an easier alternative to soldering. A breadboard is just a really easy and straightforward platform for prototyping and building circuits without having to mess around with soldering irons and circuit board design. So we're going to have a look into how breadboards work. So if we take a closer look here at the breadboard, this is how the connections work. The rows going downways are electrically common, and I'll show this with an illustration overlaid on top. These rows are all connected together. An individual column is electrically commoned together. So this column here is all one connection, which also means that the column next to it is not connected to the column to the left or right, and that's the same for all of these columns here. To connect one column to another, we actually have to use some wire. So if I put a piece of wire in one column and another column, I have now made a connection between these two columns. So these two columns are now electrically common with each other. And it's very useful to know how these are connected, because it allows you then to go on and create series circuits or parallel circuits. And on most, if not all breadboards, there is also two other connections on the side or the top, depending on which orientation you have it at, and those are the power rails. So these rails are across here all electrically common, unless you have a break on the illustration there, which means that between these breaks, this side is not common with this side. And you can see that there's one labeled negative and one labeled positive. So when I'm actually connecting power to these rails, I will connect the negative into the negative rail and the positive into the positive rail. So the top row is actually isolated from the bottom row here. And you can see that by the line going across here, showing that this is the negative and it's electrically common, and the line going across the top there, which is showing that this top row is positive and that's electrically common. But given that this is broken, it gives us the option to either bridge it and have it make it all electrical common, or we can run a second power supply and even a third and fourth power supply onto the same breadboard. So there are many different uses for it. To get started with a breadboard, you need some kind of jumper wire. And jumper wires are basically breadboard compatible wires that allow you to make connections across the breadboard. Bear in mind, you can actually just make your own jumper wires out of preferably solid core wire with a thickness compatible with the holes in the breadboard. And I'll make a little LED circuit just so you can see how everything works. Now I'm actually powering the circuit board off an Arduino here, which is just a 5-volt power supply, and again I've connected the...
So now we are not using Arduino, but we have it in here. With Arduino you can adjust the voltage you want to apply, right? But I want you to work with 9-volt battery and use resistor to bring the voltage down, to dump it down, another way to say it.
Positive and negative.
And if you have questions, and I know you should have questions, just stop me there, raise your hand, ask me what you don't understand, or where do you think there is some confusion on this, right?
To the power rails of my breadboard. So this rail is now live at 5 volts. Now bear in mind, you need to know the polarity of any polarized component that you will be using. An LED is polarized, meaning it has a positive and negative. The positive side is the one with the longer leg, or the LED will have a flat side to show you which side is negative. So to connect the LED, I've noted which side is the positive, is the longer leg, and I'm going to keep that on the left. So I'm going to put the positive leg into this side of the board and the negative into that side. So they are now in two different columns, and because they're in those two different columns, electricity will not flow between the columns. The electricity has to flow through this column, along the LED, and to the second column. The second thing I need is a resistor. So I have here a 100 ohm resistor, or thereabouts. I'm going to connect one side of the resistor to the same column where the negative of the LED is connected. So it's in the same column, and the second leg of the resistor, what I'm actually going to do is just put it round here and connect it to the negative rail of our power supply. So you can see now I've got a resistor coming from the negative rail going to the same column as the negative lead of the LED, and what I now need to do is connect another wire to the same column as the positive of the LED, which I've just connected it behind so you can see the LED, and then I'm going to go ahead and connect the other end of the wire to the positive rail of the...
It's done the same thing. So there are many ways how you can build the circuit, right? For me, I was using a jumper cable. He's just directly connected, but you are free to pick however you want.
breadboard. And there we go, you can see now that the LED is lit. So I've got my power coming from the Arduino here, and the negative is connected to this resistor. The power is flowing through this resistor to the negative lead of the LED. It's going through the LED, out to the positive lead of the LED, round and to the positive rail of the breadboard. What I'm going to do now is actually add some more LEDs to this, and we're going to add them in parallel. Noting the polarity that I placed the LEDs in the circuit board, I'm going to keep the positive on the left. So there we go, I've got my extra 2 LEDs in place. So I now need to add the extra wires to make the parallel circuit. So I'm just going to connect another wire to the positive rail of the board, and then to the positive of another LED. Then I'm going to take another resistor and connect the resistor to the negative of our second LED, and then back to the negative of the power rail. And there we go, another LED has lit, as you can see there. We've got a yellow LED lit now. So I'm just going to do the same with the last LED. I'm going to connect another wire to the positive rail, and then the other end to the positive side of the LED. And then I'm going to get another resistor and connect that to the negative of the LED, and then to the negative power rail. And there you have it, 3 LEDs connected in parallel on our breadboard.
Alright, so you get the idea? That's a very basic introduction, but I want you to get on your breadboard. I want you to start building simple things. Now, let me give you some pointers on the project that I have, 3 project ideas that I have given, right? So let me bring that up, and then I'll give you some, I'll just look at YouTube and you'll find there are many things that are given online about doing those things. Hold on a second, just stay. Let me bring that slide up from last time about 3 project concepts. So essentially, breadboard is nothing, just a holder of your circuit. And so you think about circuit, you can first sketch it on the paper, or as you will see, there's lots of ideas on those things already out there. So, and this is where you can look up and then make a list and possibly take it from there and build it. All right, so there were 3 options that I've given. FM transmitter, right? So let me go and let's do it together. Let me share my screen with you so you'll see what I'm doing. All right, you can see my YouTube, right? So if I say FM transmitter breadboard, how to make FM radio transmitter at home on breadboard. There is a video about it. It's showing you. All right, can you see my screen? All right, so what do you see? Tell me, what do you see? Do you see a resistance? You can see my pointer also.
Yeah.
You can see capacitors. There is a speaker, jumping wire. They made an antenna of some cable right here. And that's the circuit. That's it. Now I know you have not done it before. Fatma, I can't see your video. Lukman, you are hiding somewhere. All right, Fatma, what's up with your, okay. So this circuit is straightforward, but of course you are building it for the first time. I want you to build it, right? That's the whole idea. Let's go through this video. And you remember I said be creative, colorful, and confident in your project. So yes, I know the circuit is there. I want you to be creative about it. Bring something more than what.
I have a question.
Hi.
Okay.
Question. Go ahead.
Are all the parts there included in the kit you linked?
Yeah, so we sent you a link to the kit, right?
Yeah, I got it. Are all the parts inside of here?
Okay, this is where you will look at the kit, you will see what are the parts needed. Maybe you may have maybe a resistance which will not be exact resistance, maybe a little bit up and down, but that's fine. That works. You may have a capacitor here given, but in your kit, maybe a capacitor is some value, little bit up and down, it will work. But if you
speaker.
Okay, speaker. Where do you find a speaker? Speakers are, I think there is one in the kit. Let me double check. Where's the kit? It was here. So let's see if there is a speaker here. But you can find a speaker. There is a buzzer, right? Active generator. It gives you a sound, but I don't know if this is a speaker also. But the speakers can be taken from a toy. You can find a small speaker also on Amazon. But then that's where you have to see what major things are here and what small things you might want to buy separately. It's a microphone, small microphone. I'd say small component. So these are small microphones. These are small microphones, right? Yeah, they're selling too many. You just need maybe one or two. So yeah, this is where you have to like narrow down to get a few microphones. Right? Yeah, the 2Ps, yeah, see, 453.
Dr. Samir,
Yes, sir.
we're supposed to take this yellow stuff off the bottom.
No,
It's
no,
like
no, no,
sticky.
no.
Which
It's the
stuff?
sticker walls.
Hold on. Show me what you're asking.
Are we supposed to take this yellow part off?
Hold on. Yeah, yellow thing. So every breadboard has a sticking thing at the bottom. Don't take the sticker off. If you take the yellow thing off, there is a sticker. Why
Okay.
the sticker? Because sometimes you make maybe a remote control car and you put this circuit in that thing. So you don't want it to move. Maybe you make a circuit for in your room for your LED lighting. So you want to have it stick somewhere. Then we take it off. But don't take it off. There is sticky thing below it. All right. So you got some idea about the first project idea that I have for you? Got some idea about it? Yes? No? All right. So what's the second project? Light controlled light bulb. Okay. So what we need for that, let me share my screen again with you. So light controlled light bulb. There are two things that go into there. So first, let me just look for light controlled circuit. So light sensor. What we need is a light sensor, which will just look at if there is light in that room or not. And then we will turn on a light. Here we are turning on an LED, but we want a light bulb to be operated with this, right? So here, this is what you call as photodiode. So you need a small photodiode. But here is a video about it, right? Here's the circuit, how things will connect with where, right? Now, but this doesn't show us how you can make your own light bulb. Let me.
Sensor circuit you can start with, but it has some limitations like you can't control at what brightness of light the LED turns on or off. Also practically we would want the LED to turn on when it is dark and turn off when there is enough light. This circuit can't drive heavy loads too. So for these reasons we'll make a more functional circuit using transistors. The first
Okay, but we are just making a light.
thing we need to do is convert change in resistance of the LDR to change in voltage. That can be achieved by adding a resistor in series with the LDR, that's a 1 kilo ohm resistor, and connect the other terminal of the LDR to positive rail and the resistor's other terminal.
Now let me give you another idea on how can you make your own light bulb. Let's see, how can you make your own light bulb? Is okay, touch sensitive. We'll get to touch sensitive also. How to make yeah, Eunice, I don't see your video.
Well, yeah, because we can just use this one tablet. I mean, we're all three of us are here.
Okay, when you go to reach.ieee, let me share this in the chat with you. Somebody send me I need to step out for a minute. Okay, yeah, that's fine. I shared a link. Here there are some ideas also. So it says hands-on activities. And if you go skyscraper, make a light bulb with batteries. Electric, it needs glass jar, cardboard, 2 long wires with alligator clips, 8 D batteries. You already have 9-volt battery. So you can video demonstration. Okay, here's a video demonstration. So I'm just gonna lots of stuff.
Hello, my name's David.
Let's do the ends.
We are gonna move inside just so we can see better. And then we're gonna stick both of this end.
So give it a-
So we're gonna put the jar over the thing.
He has taken your graphite pencil, the pencil you write. He got the graphite out of it from the middle and hooked it up one side with positive terminal, the other side with negative terminal. And when he does that, it just gets hot.
And then we're gonna stick the other end to the
Be careful, it will be
negative.
very, very
Make
hot.
sure you hold it by its cable, because the metal can go extremely hot. Now let's see this magic.
That's graphite. It gets hot.
Wow, isn't that amazing? And this is one of the activities you can find.
So that would be something which will go into your second project, second idea.
Can you share the link to that?
I did share the link in the chat, but let me share the link to the video also directly to the Vimeo content. Oh, here's the whole video for this. Oh,
And in IEEE reach.
why is it not giving me direct link to this? All right, so that when you go to that reach.ieee.org inquiry units, then you'll have to go through and get to this light bulb with cardboard and pencil lead thing. All right, so there is touch sensitive LED controller. That's straightforward thing. Let me show you how you can think about that. So just take some pencil and you can make a touch sensitive circuit with that. Just put this graphite thing on a piece of paper and you make a circuit, or you can take what they call it's called an ink, electronics ink, electric paint. It's a very cheap thing. You can just make like a sketch like this, and when you put the finger, it completes the circuit. Your light will turn on. When you take it off, the light will turn off, and it will open the circuit. But here also, there's lots of information for that. Let me put the link with you guys. It's on YouTube as well.
Bear tutorials. Making a touch-sensitive circuit with Bear Paint. Hi, I'm Peter, and today I'm going to show you how to make a simple interactive circuit with a 555 timer and some Bear Paint. The 555 timer is a fun and versatile IC or integrated circuit that can be used in several distinct ways. However, there are loads of cool interactive circuits that can be made with this tiny little chip. Today I'm going to show you just...
Yeah, it's like...
Say it again.
Your mic is muffled.
The mic is muffled. Okay. Let me...
It was, not anymore.
Hold on. Let me try this again.
We can't hear you when the video is playing.
Okay, let me do something about it. Can you...
Make a simple interactive circuit with a 555 timer and some Bear
All right, the sound of the guy is itself not very clear.
Paint.
Let me share the link to this in the chat.
The 555 timer is a fun and versatile IC or integrated circuit that can be used in several distinct ways. However, there are loads of cool interactive circuits that can be made with this tiny little chip. Today I'm going to show you just one of them.
Of your color choice, a couple of jump wires, and 4 of these very useful paperclip wires, which you can learn how to make on BB's tutorial connecting to Bear Paint. Check it out on how to do that. And finally, a couple pages of paper so you can paint your circuits with your Bear Paint. Taking your pot of Bear Paint, a paintbrush, and some paper, we're going to get started. So the first thing we're going to need to do is to design our touch-sensitive buttons. You can think of them as a line of paint with a gap in the middle, and at this gap is where we're going to place our finger, where we will connect the circuit through our skin. So from this idea, I've made a basic design of a button with all the connections situated along one edge of the paper. And there's a slightly larger section where the gap is, where this is there to suggest a touch point.
While your design is drying, it's time to take out your breadboard so we can assemble the circuit. You can download the schematic from the text in the tutorial page so you can follow along.
Are we supposed to be doing something?
Just watching.
We're watching something?
Yeah. Can you see the video? Can you see the video?
No, we can't.
All right.
I can.
Can you see the video?
Yeah.
Yeah, I can.
I can hear it.
Let me share the link with you guys.
No, it's not.
Hold on, there's some lots of feedback. Okay, let me get the link for you guys. Okay, here's the link to the last one. All right, guys, when I mute you, you stay muted because you are just creating feedback. All right, so I guess I covered everything I wanted to show you today. Questions? Now, I'm not saying I've shown you everything, but I've shown you enough to feel comfortable building a simple thing with a breadboard. So what I've done here is just used simple concept where I can now, on that bus, I can go anywhere, bring my in, and I can turn an LED on. You can fill this whole thing with LEDs and have this whole thing light up. So, questions before I let you go? No questions? All right, Lukman, shoot. You are muted. You are muted. Go. Oh, sorry, and let me unmute you because there are some folks.
All right. So I thought this was due today, so I kind of already did it and made a video.
Okay, fantastic. So today was the concept document due, and you had to give me the preference. But if you have done it, fantastic. You are ready to make a video out of it?
I already made a video.
Okay.
But it was kind of a short video. If you wanna, maybe I can send it to you and let me know what you think.
Put some creativity in it. Put some beats.
Huh?
Put some creativity in your.
I did. I mean, I can show you if you want.
Let's do it. Let me.
Let's watch it.
Share it.
I mean,
hold on.
It was kind of short, but.
That's fine. That's fine.
You know,
fine.
And it wasn't that good. Also, I'm definitely gonna make another one. But
you are not the judge of good or bad. We will judge that. You just do your best.
Right.
Don't worry. All right. Another question.
Let me try to find.
Yeah. Let me address another question. All right. Fatma, question. Fatma said, "Can we have the deadline extended because I don't have all the materials yet?" Okay. I want to get from all of you your priority list of the projects. Not all of you have given me that yet. That needs to be turned in today. And then we can talk about extending the deadline. Sure, we can extend the deadline, but today I need all of you to give me your priorities.
All right, can you all see my screen?
All right, yeah, Lukman, I can see your screen. Go ahead.
Hey, what's up? You guys hear?
Yeah, we can hear it.
All right. Hey, what's up? So most of y'all already know me from this STEM class, but if you don't, my name's Lukman Irfan, and I made the touch-sensitive LED circuit. At first, when he said that we had to do, one of those things, I was like, oh, well, just follow a video and, it should be easy enough. But, I followed the video, that video, and I found another video, followed that again, and it just really wasn't working out. So the main thing that I had a problem with was the touch sensor part. So I was like, okay, let me just try to replace that with a button, and maybe that will work. And after a lot of, at first it wasn't working, and I had to kind of mess around with it, and finally it worked. And yeah, so this is the final product.
Yeah, so that's what I got.
But you know what? You are using a switch to turn it on.
Yeah, I know. I have to do the touch sensor part.
It's like touch and turns on and off. It's more like going to bed. You just want to touch your lamp. You don't want to find the switch to turn it on and off.
Yeah.
All right. So very good. No, this is great. This is good start. I was make it 4K if you can, at least 1080p.
I know. I think it was, but because it was on the drive and stuff, I think I had to lower the quality of it.
Okay, but yeah, no, I will want a 4K if you can on this one. All right, very good. So yes, we all have to make a video. How else will you share it with us? It's okay. You don't have to be really, just take a phone and show how it works and what all went in making it. And we can have somebody help you, or we can take it and make somebody use your raw footage into creating something nice. But hey, this is a competition. We all are competing with each other in-house, right? So I mean, you make a video because we are gonna beat the other kids. That's why I was hoping if you can get some good videos. All right, questions? All right, so I sent a doodle link because I know and I hope you guys need more help in how to do this. And that's where Haneen and I want to be available to you guys to troubleshoot these things with. I know these things, when you are starting, you'll have trouble in, okay, if the circuit is not working, the connection is not big. So we would like to help you troubleshoot there. So fill out those doodle poll. Ignore the dates, just focus on the days and times if those work for you. Click all of those time slots that work for you. Then we will make those days accordingly the best ones. All right? Questions? All right, very good. Talk to us as you build things. Okay, first of all, today I want to get everybody's preference in so we can assign those things to you. I don't want everybody making one project. So we need to make distribution. All right, I'll let you go then, guys. Take care. I'll see you inshallah next week.